Hey, welcome to Code. Today we'll be solving one of the interesting questions in Leetcode called number of subsequence that satisfy a given some condition. So without wasting any time, let's deep dive into this video. Let's first try to understand what the question is trying to say. So the question says we are given an integer array called lum and a target value called target, and we have to find how many subsequence are there in that num that satisfy the below condition. So what is the below condition? Below condition is that the subsequence minimum element and maximum element should be less than or equal to my target. Okay, so let's see why an example on what the question is trying to say. Okay, so I've written one example here. We are given an input as 3, 5, 6, 7, and we are given a target as 9. We have given a target as 9, and we have to find how many subsequence are there that maximum and minimum sum is less than or equal to 9. How many subsequence are there? So the first possible subsequence can be 3, and the next possible subsequence can be 5, the next possible subsequence can be 6, 7, 5, 3, and so on. So I've written all the possible subsequence that is possible out of this array. Okay, now for each subsequence we have to check if it satisfy our condition. So what is the condition? The condition says that minimum element of the sequence plus the maximum element of the subsequence should be less than or equal to our target element. Okay, so let's try to check one by one if it satisfy this condition. Okay, so let's check the first subsequence. What is the minimum element in this subsequence? The minimum element is 3. What is the maximum element in this subsequence? The maximum element is nothing but 3 itself. So the sum of these two is 6. So is 6 less than 9? Yes, 6 is less than 9. So hence 3 is one of the valid subsequence which we are looking for. Let's see the second subsequence. Second subsequence is 5. So what is the minimum element in 5? 5. What is the maximum element in 5? That is 5. So what is the sum of those two? The sum of those two is nothing. Is 10 less than 9? No, 10 is not less than 9. So 5 is not one of our possible answer. Similarly, check for 6, 7. So if you see 6 is also not a possible answer, 7 is not a possible answer. Now let's check the 3 and 5. So if we check 3 and 5, what is the minimum element in 3 and 5? Minimum element in 3 and 5 is 3, maximum is 5, the sum will be 8. Is 8 less than 9? Yes, 8 is less than 9. So this 3 and 5 is one of the possible subsequence. Now check for other also. 3 and 6, yes, this is one possible subsequence because its sum of maximum minimum is less than target. Is 3 and 7? No, it's not, because its sum is 10 and we need a value less than 9. Similarly, this is not a possible subsequence, this is not a possible subsequence. But if you check this subsequence, what is the minimum element? The minimum element in this subsequence is 3. What is the maximum? The maximum is 6. That is it less than, is 9 less than equal to target? Yes, 9 is less than equal to target, hence this is one of the valid subsequence. And so if you do the similar check for all this will not be one of the valid subsequence. So what is the total number of element that satisfy this condition? The total number of subsequence that satisfy this condition will be 1, 2, 3, and 4. So what will be our output? Our output should nothing but 4. That is, there are 4 subsequence. Which satisfy the given condition. Hope you have understood the question. Okay, so now let's try to build the intuition how we can solve this problem. Okay, so I'm taking the input as similarly what we have given in the question. So let's first see what will be the total number of subsequence that is possible out of this subsequence. So basically the total number of subsequence that is possible will be 2 to the power n, where n is the length of the array. So what is n here? N is right now 4, that will be 2 to the power 4, which is nothing but a 16. So what is the total number of subsequence that is possible in this with this subarray? That is 16. How we derive to this formula is basically nothing. We just have to see like what is the possible number of ways to do this. So basically we can select this value, or we can reject this value. So there are total two ways to select this. Similarly, select and not select. Similarly, there are another two ways to select and not select, two ways for this and two ways for this. That is nothing but again 16. So yeah, so this is the first thing which we want to know, what will be the number of possible subsequence. Okay, now second thing which I try to explain will be, uh, let's say one of the possible subsequence is 3, 5, 6 and 7. Okay, let's say the complete subarray is one of the subsequence. Okay, so now what we need to do for each subsequence is that we are just concerned about the minimum element of that subsequence and the maximum element of the subsequence. We are not actually concerned about these values here right now, because these two values will be the uh, value that we need to compare it with the target element. Okay, so this is the second thing which you want to know. And the third thing, let's say I am given an element and I am given this subsequence as 3. I don't know these values right now, and I know the minimum element and I know the maximum element as 7. Okay, I don't know these three values right now. So what will be the total number of possible subsequence that can be formed with having 3 as minimum and 7 as maximum? The total number that can be formed will be so here let's say if there are three values right now that satisfy this condition, so the three values will be 2 and 2 and 2. Okay, so for these two values are possible and two values. So total, if 3 is minimum and 7 is maximum, and there are three values in between the minimum and maximum, then there will be total 8 subsequence possible, that is having 3 as minimum and 7 as maximum. Okay, so hope you have understood these three things. So based on these three things, we'll be trying to solve our question. Okay, so now let's try to come up with an algorithm to solve this question. Okay, so I'm taking the same input as an example right now. So as we have established that we are not concerned about these middle elements right here, we are just concerned about the first element and the last element. That is not first, actually it should be the minimum element and the maximum element of the subsequence. And if we see that the sum of the minimum and maximum is less than target, we'll say okay, this is one possible pair. And once we know that this is one possible pair, so we can just find the length, the number of elements that comes between that pair, and we can just do 2 to the power number of elements in between those pair. N is the number of elements that's between those pair. Okay, so this is what we'll by this approach we'll trying to solve this problem. Okay, so now my problem has reduced to nothing but find the total number of pairs whose sum is less than or equal to the target. How many such pairs exist whose sum is or equal to less than target? Let's try to see how are these such pairs here. So if we see, the one pair can be 3 and 3, the second pair one pair can be 3 and 3, the second pair can be 3 and 5, the third pair can be 3 and 6, yes, because it's less than 9, so third pair can be 3 and 6. Is there any other pair that exists? Okay, no. Now we just have to check what is the number of elements in between them, what is the number of elements in between them, and what is the number of elements in between them. And In between, I mean the number that is greater than equal to 3 and less than equal to 6. This is what we need to find, and once we have it, we'll just do a 2 to the power n. It will be the number of subsequence that can be formed using 3 as the minimum and 6 as the maximum. Okay, so let's see how we can do this in an optimal way, how we can find such pairs in an optimal way. Okay, so again I'll take the same input here, and once I have the same input here, uh, what we can do is right now we can sort this input. Okay, so since this is already sorted, I can just write it there. Now first thing what we have done is we have sorted the input. Once we have sorted the input, we can use something called as two pointer, where we need to find the pairs that is less than or equal to my target. So the sum of that pair should be less than or equal to my target. Okay, so let's start with let's initialize my first pointer here with the first element, and second pointer here with my last element. Okay, now let's say I have let's try to do the sum of these two elements, that is 7 plus 3 is 10. Let's say my target was 9 here. So is 10 less than 9? No, 10 is not less than 9. So if 10 is not the line, so these 7, if this 7 can not form the pair with the minimum element, can it form pair with anything greater than 3? No, right? It cannot form any pair with, if it cannot form pair with the least number, it can not form pair with the more bigger numbers. Okay, so hence we can just ignore this 7, that is this 7 cannot form pair with anything. So we'll decrease my j to this element. Now what I will do is I'll again check if this can one be the possible pair 3 and 6. 3 plus 6 is again less than equal to 9, right? So this is one possible pair. Now we have got one pair. Once we have got the pair, what we will do, we need to check what is the subsequence we can find using this pair. So the number of elements in between them, let's say I'm writing down the index, so the number of elements in between them will be nothing but 2 minus 0, uh, that is 2. Okay, so 2 to the power 2 is 4. So the number of subsequence that can form using this element as 3, 5 and 6 is 4. So what are those possible subsequence? You can write, I'll just quickly write this. One possible subsequence is 3, one is 3 and 5, another is 3, 5 and 6, and what will be my another one? Okay, so another subsequence will be 3 and 6. So total there will be 4 subsequence. Hence this 4 is coming out of these 4 subsequence. Once we are done with this, we'll say okay, now try to increase my I. So j will remain at this position and I will increase to this. Okay, so now I'll check if 6 plus 5 is less than 9. No, 6 plus 5 is not less than 9. So we'll try to again increase, basically we need to decrease our j. So once we can do is we can decrease our j. Now again we can check if 5 plus 5 is less than 9. No, then we'll again try to decrease our j. So at this point, since j have passed my I, so we can stop, because now it will be repetition, because 3 and 5 we may have already checked. So we can basically terminate our loop, and that's it, and basically we can get an answer. So first thing we did was we have sorted our array. Second, what we need to do is basically use a two pointer approach, where my first pointer will be pointing to my first element and the second pointer will be pointing to my third element, and here we'll check if my pair is less than target. If that's the case, then less than equal to, then we'll try to calculate our answer. Okay, so this was the approach. Now let's try to write the code using the same algorithm what we discussed here. Okay. Okay, so here I am in my coding screen. So let's write the code. I'll be using Java to write this code. You can try to write the same code in any other language. Okay, so the first thing we need to do is we need to sort the array so that we can actually apply the two pointer approach. So we'll just write this arrays dot sort. Now what we need to do, we need to consider two pointer. My left pointer will be 0 and my right pointer will be the length of the element. Let's say length was n, so my right pointer will be n minus 1. Let me take n as nums dot length, and I'll also take a result which will store my result. Right now it is a 0, and since we need to return the modulus, we will take something called as mod, and we can simply write it as 1 e9 plus 7. Okay, so now let's try to do a two pointer. We have to move from left less than equal to r. Okay, so what we'll do, we need to first check if the sum of left and right is less than target. So we'll check if nums of left plus nums of right, if it's less than or equal to. Okay, so if it's let's say, let's first see if it's greater than target, then it means we need to reduce our pair. So how we can reduce it? We'll just simply write r minus minus. This will reduce my pair sum. Else what we can try to do is, else if it's equal to or less than equal to target, we'll just calculate a result. So what will be my result? It will nothing but result plus basically we need to get the length of the uh, subsequence here. So length will be right minus left. Once I know the length, I have to say basically 2 to the power length. Let's say I have already calculated my power here, so this will return, let's say this will return 2 to the power len. So and we'll quickly do a mod so that it don't overflow, and that's it, and we'll return my result. But before it running this code, what we need to write is we need to pre-calculate this power. How we can do this is we can just take a power sub array of, okay, we will take a power sub array, and now my power of 0, we already know power of 2 to the power 0 is 1, and for the rest of the element I'll try to fill it from 1 till my last element. And what will be my power of I at any given point? Power of I will be my power of I minus 1, the previous, into 2. And again we have to take a mod so that it don't overflow. And yes, that's it. I think that should work. Let me try to run it. Okay, so there are two compilation. Okay, my bad, here it should be int. What is the second error? The second error is yeah, that's it. This was the only error I see here on line 11. Now let's try to compile this again. Not sure why I wrote this. Okay, my bad. I think this should work this time. It should be arrays dot sort. And these thing happens when we code. Okay. One thing here we are missing. We are not reducing our length array. Okay, so once we have got the pair, we have to actually not reduce, we actually have to increment a length so that we check for the next element. Okay, finally. Yeah, that's it. I pretty much it. Hope you have enjoyed the video. Uh, don't forget to leave a like. See you on the next one. Bye.